So we're going to talk about various hazards this week. We go through aviation, icing. We talk about things like low ceilings, visibilities, and lightning and all that. So we're covering 3 chapters this week. First one, we talk about icing. Icing can become a major problem. A few years ago, out of JFK area, LaGuardia, there was a layer of icing around 12,000 feet. So if that was occurring, think about the pilots that are coming in to land there. Sometimes they have to circle, and a lot of times it's between 10 and 12,000 feet that aircraft is going to be circling. So what they found was a lot of the aircraft were coming in and landing with heavy amount of icing on them. So they actually had to work around the icing issue where they stacked the aircraft up to land at the airport, which was really in bad conditions anyways, as far as low ceilings and visibilities. So what they did was, because of that, it slowed air traffic down even more, and delays got even longer for commercial flights. So icing, while yes, many aircraft have de-icers, there are still instances where it becomes critical. So with that in mind, let's see if we can move along. Here's your basic icing forming from carburetor icing. Interestingly, and I did not know this, notice I have dew points up here and temperatures up here, and I'm getting icing in 70 degrees, significant icing. So icing can occur at any temperature sometimes, depending on dew points to go with it and all. So it was an interesting exercise here, and you're going to get this in a question in your test about when icing can occur or not. And this is a great graph for that source. So icing can occur all over an aircraft. Usually it exists from rollback of raindrops. Raindrops can be in different sizes. The bigger the raindrops, the slower it's going to freeze and the more it's going to roll back, which can cause some problems. The smaller the raindrop, maybe the more instantly it will freeze and just be on the very front of the aircraft. Also, aircraft will get icing on the ground. That's why we go through de-icing procedures every time you take off. I had a flight to Florida once where the frost was on the plane. It was hardly visible, but we de-iced the plane here at Norfolk so we could take off and fly to Florida without any issues. So that is something to be cognizant of as well. If temperatures are going below freezing or not, are just close to freezing, you may have some icing on your plane. So here's an icing, rime icing occurring on the edge of the wing here where you have some clear icing forming. Here you can see the whole front of an aircraft coated with ice. NASA and NOAA send aircraft into extratropical cyclones to study them. And as part of that, they've run into some significant icing issues at times. PIREPs. If you were on the ground and used windows to look out, we'd have observations of what's going on. Well, pilots do the same by literally doing these PIREPs. These PIREPs are invaluable. If you contribute information to them or take information from them, they can tell you what is going on at different spots of the atmosphere. While I can give you a forecast that might indicate that, I'm not there to see it like you are. And this is what you're really getting with pilots when their instruments, by reporting light icing or moderate icing, reporting wind shear, all of that contributes to your knowledge as you're flying. So it's really neat to plot it up or whatever, and I know you can get them while you're flying as well. So here are some instances of icing forming. Notice more in colder temperatures, you get different varieties of icing, and the aircraft can get different methods of icing as well. the more water in a cloud, the more icing can occur, obviously. There was a commuter aircraft. This was 1994. And it occurred in the cold sector, but just before a warm front. So let's go to that front here a minute. Here's where the aircraft crashed. So we have a warm front moving north. Temperatures are cold, not necessarily at the ground level, but aloft there are lots of moisture. Think about it, warm air rising, slowly being lifted up over here, the cold air mass condensing, lots of low clouds, visibility down. So as this aircraft was flying through this lower cloud level, it hits an altitude where ice is going to develop. Because if you go down to a certain point, the cold air is going to be above you, right? I mean, the warm air is going to be above you, so you wind up in the cold sector again, and you start getting icing. But this, you've got to understand, around winter extratropical cyclones, there is definite potential for icing ahead of a warm front. That is the worst area to be in if you're worried about having icing. That's an area you want to avoid. Oh. And here you can see it again, warm air coming up and overriding very strong cold air to the north with that large 1032 high. Created lots of icing issues. Mountains can cause them as well. Obviously, if your air is being lifted up a mountain slope, it's getting colder, you can wind up in an icing regime as well. Notice the number of icing days. West Virginia, right along the east slopes of West Virginia, there's a lot of icing days. Up in New England as well, where nor'easters are driving northward, pushing the warm air north, getting the low clouds, and over the upper Midwest as well. Much less over California in this area compared to the other ones. So, obviously, you need to know your aircraft, what it's capable of. And here, for example, is a depiction. You can get these from Aviation Weather all over the place, charts that will show you where the icing freezing level is and how to deal with it. So with that, let's move on to instrument weather. Being instrument rated is what all commercial pilots wind up being, I believe. And so let's take a look. If you were at an airport and flying in, we know visual flight rules. Everything's easier when you can see well. You can see the other aircraft, you can see the ground. Visual flight rules are ceilings are greater than 3,000 feet. So if you have no ceiling, hey, no problem. However, instrument flight rules develop from 500 feet, so less than 1,000. Yes, off land in those conditions, but it's not recommended. And I have been in aircraft before that have waited out fog where the visibility is a quarter mile or less. And that was typically the threshold at which you could not take off at that airport. I believe that Charleston, West Virginia's airport criteria is a half mile actually for visibility. So, and ceiling must be above 250 feet. But you can find these at various charts around the country. And think about it, if you're a VFR rated pilot, you fly up into a cloud. However you got there, we'll say you were moving, think you're going to get in ahead of a front into an airport, and oops, that front is aloft. You run into the clouds earlier, even though maybe down lower is clear, you can't go too low. So you're in the cloud layer. If your visual flight rules, you can easily get disoriented, not know which way's up or down. So these are all issues at visual flight. That's why people that are flying VFR need to avoid these significant cloud layers. They need to be able to have some references to know where things are. So what causes those low conditions and stuff? As I would say, you can see a warm front's moving towards you. You can get low clouds on the north side of that front. A cold front's moving towards you. Maybe you have cumulonimbus clouds developing or a bunch of cumulus clouds developing. What about over the Great Lakes in wintertime where the air is coming across the lakes, coming into West Virginia? It's hitting the mountains. It's rising. The air is kind of unstable because it's really cold air. You have picked up some moisture from the Great Lakes. You get clouds. So another chance for IFR conditions. Most METARs will indicate IFR conditions, and the TAFs as well, showing up pretty well. If you're flying through a cloud layer and then all of a sudden pop out, obviously you can see. You need to know how low you can go if you're going to be popping out into the clear air or not. Precipitation can reduce it, especially snow. Rain is really actually something that, it can get intense rain, but most of the time in an extratropical storm in the wintertime or whatever, rain, you're going to get visibility of 1 to 3 miles. You may actually not even have IFR conditions in the rain. However, if you have snow, very quickly the visibility could go below 1 mile. Get moderate snow, it's a half mile. Heavy snow is a quarter mile. So yes, visibility can lower very fast here. And you can see here on this front depiction where two areas, warm air rising up. So many times when a warm front is coming towards you, you're going to get very low clouds, very low ceilings. I actually have some of your labs where I have a very low ceilings occurring over Pittsburgh and over Washington, D.C. If you move, the reason they're occurring there is there's a warm front lifting north. Once the warm front passed, if you look south of that area at that time, you would see ceilings lifting up to 4,000 to 5,000 feet, basically going to a VFR condition. So sometimes it's just a matter of waiting out the conditions to get through these. Smoke and haze can do it as well. Obviously, the smoke layer may get up around 2,000, 3,000 feet. It's up there. And really, in the haze as well. One of the interesting things is the haze and smoke will tend to many times rise up to the top of the boundary layer, or the layer where the air is mixed through from the ground to that layer, that level. After that, when you get above that level, you may actually get smoother flight, and you get better visibility sometimes. Storms are a distinct possibility in the western United States, not so much around the eastern part of the country. So here's the climatology, for example, of dust, and you'll notice that out in the southwestern United States, there can be significant hours of dust each year. I was in Phoenix for a conference one time, and the interstate that runs through there, and I can't think of it right now, the day before had literally been closed because of a dust storm. It had caused a number of accidents. Think about it, what it would do. You're flying if you're trying to land in Phoenix at that time. Fog. Fog's a big problem in West Virginia. Think about it. You have mountain valleys. Cold air drains into these valleys. You get great radiational cooling. You wind up with fog. One final chapter here. We're talking about lightning. Lightning can definitely be a problem. It's not likely to hit your plane. However, it can. And if it does, it will cause major damage to your electrical systems. But think about it, lightning is only a very small area. So yes, the odds on you getting hit are very small. If you happen to be flying around a thunderstorm for some reason, I can't explain why you want to, but it is something you need to be aware of. The ozone layer. Ozone is bad for our health. And the ozone layer is higher up into the stratosphere. So if you, for some reason, are flying in the stratosphere, and many aircraft do, think about it. If you have a strong low coming down, developing here, Near that low, the troposphere is going to drop down lower. So the tropopause is going to be lower. So you're going to be actually flying higher in the stratosphere. You're staying at your normal 35, 40,000 foot cruising altitude. You're actually going to be more into the ozone layer. Yes, you're not in it long or any kind of conditions where it can cause a major problem to your health. But knowing that is something to just be aware of, that you're going to be more in the where lows are stronger. The tropopause will be lower. Volcanic eruptions, they put out a lot of dust, debris into the air, something aircraft do not like, causes damage to your wings, to your engines, all of that. So basically the whole idea is to avoid any area. And think about it, ash will move with the wind, so it can literally have a major eruption somewhere up in Alaska in this case, and wind up coming down the western side of the United States following the wind. So you would have to be very careful on where you were flying. You may not even be near the volcano and still have an ash cloud to deal with. So this is what I wanted to really give you an idea about. I kind of just focused on the books, but these are questions, types of questions you're going to see applied this time. So I hope you got something out of it. Let me know if you have any.